Today's topic is controlled rectifier. Controlled rectifier has two parts. One is single phase rectifier, another is three phase rectifier. Then single phase rectifier also has two parts. Single phase half wave controlled rectifier and single phase full wave control rectifier. Now we are going to discuss about single phase half wave control rectifier. So single phase half wave control rectifier with purely resistive load, that is R load. So the circuit diagram will be look like this is the input AC source, this is Vs is equals to Vm sin omega t. This is the thyristor T1 or SCR silicon control rectifier. This is gate, this is anode, this is cathode. This is the control element. We can control the output by controlling the gate pulse of this SCR, and this is the load RL. Okay, and this is the output voltage V0 across. We have to find the V0 appeared across RL by controlling the switch, that is SCR here, against the input voltage Vs, that is Vm sin omega t. So if we are going to draw the waveform of input and output, now suppose this is the waveform for Vs. So as this is continuous sinusoidal wave, so with time this will flowing as like this. This is pi, this is 2 pi, and the time period is 2 pi. Okay, now if we are going to find out the output voltage waveform against the time period, then here the gate pulse is very useful. Suppose we are triggering the thyristor, that is SCR, when the input voltage waveform covers 30 degree of its path. This is overall pi means 180 degree. During positive half cycle the sinusoidal waveform covers total 180 degree. So if I trigger the SCR when the input voltage covers only 30 degree, then before 30 degree the output will be 0. Suppose this is 30 degree. So before 30 degree the output will be, there will be no output because SCR is off. After 30 degree the waveform will be like this. Okay, so waveform will be like this during positive half cycle, and during negative half cycle there will be no output because there is using a one SCR is there, So when the anode is getting positive and cathode is getting negative, then only the thyristor will be forward biased. And during negative half cycle, the cathode is getting positive and anode is getting negative. So even with gate pulse is energized, but the thyristor will be in reverse bias condition during negative half cycle. So during negative half cycle, we do not get any output voltage. Okay, then again we are getting output voltage after 2 pi plus triggering angle, then also after 30 degree we are triggering, so output voltage will be like this. And this is, we are getting 0 voltage during negative half cycle. Okay, this is the output waveform. And what will be the gate pulse? What will be the voltage at the gate? The gate pulse voltage, that is Vg, only will be at 30 degree. So during 30 degree, this is the gate pulse potential, that is one pulse. This will be the gate pulse. Okay, now if we are going to calculate the output average voltage after conversion from AC to DC, rectifier converts alternating current into direct current. So what will be the output average voltage? If the peak voltage is Vm, then what will be the average voltage, output voltage? This is the V0. So for finding V0, that is V average at output, average means during one time period, that is 2 pi, we are taking some samples, that is say we are taking 2 pi number sample during 0 to 2 pi times, and if I add those samples 0 to add that over that 0 to 2 pi time and divide that summation by total time period, then we get the average value. Okay, so here 0 to 2 pi time, the total value of the output will be 0 to 2 integration of the waveform 0 to 2 pi Vm sin omega t d omega t with respect to time period divided by total time period, that is 2 pi. Okay, that means 1 by 2 pi. After solving that, we get 1 by 2 pi. Vm is the constant term into Vm, and 0 to 2 pi sin omega t d omega t. Okay, so here we are the whole summation. Here we are dividing the whole summation into some section. Suppose during 0 to 2 pi time, there are so many small sections. Okay, this is one section, this is another section, and this is another section. In first section, this angle is called alpha, that is firing angle. Alpha is called firing angle, up to which the output will be 0. Suppose that means we are sectionalize this the summation, then 0 to alpha, during 0 to alpha sin omega t d omega t plus, this is alpha, this is pi, alpha to pi sin omega t d omega t plus, this is pi to 2 pi, pi to 2 pi sin omega t d omega t. This summation is nothing but 0 to 2 pi sin omega t d omega t. Okay, we are just sectionalize the summation. Then we get Vm by 2 pi into, during 0 to pi the output is 0, so we are getting 0. During pi to alpha we are getting some value. So during 0 to pi to alpha, the integration is minus cos omega t alpha to pi, and also during pi to 2 pi the output will be 0. So Vm by 2 pi into minus cos pi plus cos alpha. Vm by 2 pi, value of cos phi is minus 1 plus cos alpha. So Vm by 2 pi 1 plus cos alpha. This is the formula for V output. Okay, this is the formula for V output voltage for a half wave controlled rectifier. The second topic is single phase half wave control rectifier with RL load, that is resistance inductance load. This is the RL load. You can see the difference with RL load and RL load as the output waveform. This is the input waveform Vm sin omega t, and this is the sine wave input. So if I trigger the thyristor at angle alpha, that is, this is the angle alpha, then after alpha the waveform will start. During positive half cycle the waveform will be like this. This is the output voltage waveform during positive half cycle, and during negative half cycle the thyristor should be off due to the reverse bias across it. But as we are using a inductor here, we all know that inductor stores energy, and inductor does not allow to change in current within it. Inductor does not allow change in current within it. So during positive half cycle the inductor will charge, and during negative half cycle, as the thyristor is reverse bias, no current will flow to the in load, so the inductor will start to discharge its charge. So as the inductor will not change in, will not allow to change in current within it, so it delivers a positive bias to the thyristor during negative half cycle, so until the inductor will get fully discharged. So during negative half cycle we are getting a slightly negative voltage across the load until the inductor get discharged up to this much. Okay, and after that during whole negative half cycle we are getting zero output voltage. Then again after at angle alpha, that is here, this is the pi plus alpha angle, this is pi and this is pi plus alpha. After that we are also getting the waveform like this, and okay, this will be the output waveform due to the RL load. And also the VGO will be like this. We are applying the gate pulse after alpha, the gate pulse after alpha. This is the pi plus alpha angle. Okay, so if we are going to calculate the output voltage waveform, output voltage formula, then the V0 equals to V average at output. Similarly, the summation of total voltage during one time period of the waveform, that is 0 to 2 pi. And this is 2 pi, sorry, this is 2 pi, this is 2 pi plus alpha. 0 to 2 pi sine Vm is the constant term, sine omega t d omega t divided by 2 pi. Okay, so if I sectionalize the whole integration part, then we are getting 0 to alpha sin omega t d omega t pi to pi plus this is pi and this is the pi plus alpha. So pi to pi plus alpha sin omega t d omega t, and the measured part is alpha to pi sin omega t d omega t plus pi plus alpha to 2 pi plus alpha to 2 pi sin omega t d omega t. Okay, this is the whole part. Now from waveform we are getting here during 0 to alpha you are getting the output 0, during pi to pi plus alpha you are getting output that is minus cos omega t pi to pi plus alpha, and during alpha to pi you are getting output voltage that is minus cos omega t alpha to pi, and during pi plus alpha to 2 pi you are getting also output 0. Then by calculation, after calculation we are getting minus cos pi plus alpha minus cos plus cos pi and minus cos pi plus cos alpha. Okay, so after that Vm by 2 pi cos a plus b, the formula will be applied here, minus cos a cos pi cos alpha plus sin pi sin alpha plus cos pi minus cos pi plus cos alpha. Cos pi will be cancel out. Vm by 2 pi, value of cos pi is minus 1, so minus 1 and minus 1 minus cancel out, that is plus cos alpha sin pi equal to 0 plus cos alpha. So Vm by 2 pi into 2 cos alpha, that is Vm by pi cos alpha. This is the formula for output voltage of half wave control rectifier with RL load. So with RL load the V output will be Vm by pi into cos alpha, where alpha is the firing angle. Okay.